Hello, everybody. It's Mrs. Pound, and I'm back with another section in Chapter 5.2 on weather. Today, we are going to talk about storms from section 5 to 8. Now, storms are even significant in the Bible because, as you would recall, in Luke chapter 8, verses 22 through 25, in that passage, the disciples are caught in a storm with Jesus in the boat, and Jesus is sleeping, and they wake him up, and they are just freaking out because they think they are going to die. And I'm sure you have been in some bad storms before, especially thunderstorms can be very scary, where that are just very violent and are scary. Storms can be scary because they have a lot of energy, a lot of power. And so the disciples were afraid for their lives, but Jesus calmed that storm. That storm listened to him. That big, huge, powerful storm listened to him because Jesus is God. Um, because he created everything, all of the forces that create that storm, and they listen to him. And so, just an example there of how storms are used in the Bible. And also, I would say, not only does Jesus have power over physical storms like uh, thunderstorms, but he also has control over the storms in our lives. And so, when we have a storm in our life, we need to turn to him because he has control. If he can control a storm like that, he can control our lives too. So, our objectives for today are to identify conditions necessary for a blizzard, model the stages of a thunderstorm and the formation of lightning, and compare the nature of a tornado to the nature of a hurricane. Now, in our area, we have had blizzards, so let's talk about that first. So, for a snowstorm to become a blizzard, the snowstorm must have wind speeds at 56 kilometers per hour for at least 3 hours. So this is not just our average everyday snowstorm. This is blowing winds for a long time, blowing fast winds. And we know blizzards can be really dangerous because they lower the visibility as well. Visibility is reduced to zero point 0.4 kilometers or less. And in fact, it would be very hard to see these guides along the road, and you would need those if the wind blew the snow over the road and completely covered it, or you could end up driving in a field or worse. Now, the most violent weather can be produced by a cold front, and in the background, there is a picture of a tornado, and I'll talk about those a little bit later when I talk about hurricanes. This tornado is over water, and so we would call that a water spout. Now, lightning is the electrical discharge of energy from storm clouds. This is another type of storm that commonly occurs with cold fronts. So, how does cloud to ground lightning form? It forms when water droplets or ice crystals move around inside the cloud. As they hit each other, electrons are knocked off and charges begin to accumulate. It's a lot like when we've talked about plasma, where the gases are moving around so fast that they knock the electrons off of each other. Well, that is what's happening here. It's not plasma, but it's water and ice crystals. The positive charges collect near the top of the cloud, and the negative charges collect near the bottom. The negative charges attract positive charges on the ground. And a stepped leader, which is the beginning of a lightning bolt, reaches down from the cloud and a return strike reaches up from the ground. So the lightning just doesn't go from the ground or the cloud to the ground. It actually comes from both directions. The pressure becomes great and the charges are released as lightning. Now, also with lightning, we get thunder. This is the sound that results from the rapid heating and expansion of air that accompanies lightning because lightning gets up to 30,000 degrees Celsius. That's really hot. Okay, that is really hot. So, that rapid heating and expansion causes thunder. And another thing about thunder is we always see the lightning before we hear the thunder, unless it's really close, because sound travels slower than light. And so we can also use that fact to estimate how far a lightning strike is from us by determining the time difference between when we see the lightning and we hear the thunder. Now, a hurricane gets its energy from warm oceans. What happens is the warm water causes air to rise, creating an area of low pressure. We've talked about this. Um, that area of low pressure, there's high pressure outside the low pressure. The high pressure moves towards the low pressure, creating winds. And so we have these swirling winds into that low pressure area. And these storms are have a lot of energy associated with them. There's so much energy in a hurricane that if we could harness that energy, it could supply this electric power for the United States for 6 months. Okay, so a lot of energy is in these storms, and they are huge storms that we can easily track. We can see them forming out over the ocean, and we can see them coming into land. Now, remember I said I would talk about tornadoes. Tornadoes, on the other hand, they are formed when we have a thunderstorm, usually. There are signs for them, but they're much more unpredictable, as in, we don't watch them for days. They're very fast occurrences. We have a little bit of warning sometimes, but not much, not like a hurricane. For a hurricane, we can usually have a couple days to prepare, not for tornadoes. Now, like the hurricane, it also is an area of low pressure rising with the high pressure winds wrapping around it. Okay, the high pressure moving into the low pressure, the spinning winds. Um, but it's a much smaller storm, but much more unpredictable as well. And so with a tornado, you can actually have the case where you can have a house on one side of the street destroyed and a house on the other side of the street not even touched. Um, so, some differences and similarities there between our tornadoes and our hurricanes. Now, with the tornado, if you are listening, this is to show that you are listening, go ahead and up near the statement that cold fronts produce some of the most violent weather, draw a tornado. Okay, so draw a tornado next to that statement. Now, our objectives today were to identify conditions necessary for a blizzard, model the stages of a thunderstorm and the formation of lightning, and compare the nature of a tornado to the nature of a hurricane. Don't forget your 5 questions, and I will be back with more about weather.